Okay, the sine rule. Well, this is used for finding missing sides and missing angles of non-right angled triangles. And if you think about it, this chapter's been, it's called right angled trigonometry, but in actual fact, we've done a lot with SOHCAHTOA, which is all about right angles. So what happens when triangles aren't right angled? How can we find missing sides and missing angles? Well, we use this rule, and this rule, it looks like there's three parts, but there's really only two that we need. And it's saying A, some side over the sine of the angle opposite it, equals any other side divided by the sine of the angle opposite. We usually don't need the third, but that's also true, that this side divided by the sine of that angle. These would all be equal. And we can use that property to find missing sides that we're going to see. So if you're finding a missing side, you use the formula this way. If you're finding a missing angle, we're going to flip it over. It still holds true, but it just saves us an extra step. So we're going to use that one if ever we're finding any missing angles. Okay, let's just get stuck straight into using it. So again, I don't think in terms of A's and B's. I think in terms of pairs of values. I will usually draw a pair of arrows like this to remind me which link and to remind me that this is actually the appropriate rule to use, because you can really only use it when you've got a cross like this and you've got all the elements except for one. And then I'm finding a missing side. So the missing side version of the formula is A on sine A equals B on sine B. Notice I'm not labeling A's and B's and things. I'm just thinking in terms of missing side over the sine of the one that's opposite it, sine 50, equals other side, 4.1, divided by the sine of the one opposite it, 37. Now, how am I going to get x by itself? Times both sides by sine 50, times by sine 50. And then, of course, they're going to cancel. That was the purpose of it. So I end up with x equals 4.1 over sine 37 times sine 50. Calculator. And I used divide there, you could have used a fraction. So we end up with x equal to 5.21. And we're going to one decimal place. So it's going to be 5.2 to one decimal place. And the units there were, well, we didn't have any units on that diagram, so 5.2 is our answer. Okay, so that's for finding a missing side. Okay, let's look now. Here's one where we're going to be, looks like we're finding a missing angle, doesn't it? All right, so if we look at this question, Hannah is standing 4.5 meters from the base. Hannah's standing 4.5 meters from the base of a 3 meter sloping wall. So there's the wall. She's standing 4.5 meters from the base of it. The angle of elevation, oh, okay, so we're looking up to the top of the wall is 36. Find the angle theta at the top of the wall to the nearest minute. Okay, so it looks like it's a sloping wall, isn't it? Yes, that's a sloping wall, that's why. Okay, so either way, we're finding this angle here, aren't we? So, use the pairs. I think the arrows are good. That goes with that, that goes with that. And then I'm finding a missing angle, so I write my rule down like this, don't I? So it's going to be, this time, sine A over A equals sine B over B. And we talked about that at the start, that if you are finding a missing angle, you use this version of it, the flipped version. just saves you an extra step. Then we start putting in those bits of information. So it's going to be the sine of the missing angle. I always start with the one that's missing. So sine theta over 4.5 equals the sine of 36 over 3. Okay, I want to get the sine theta by itself. So get rid of the 4.5. What am I going to do? Times by 4.5 times by 4.5. Cancel, cancel. Now, I'll grab my calculator and I'm going to do this. Now, bear in mind, I've got sine theta here. So it's sine theta equals, let's do this bit over here. Put it there so you can see it if you want. So we've got, so to do this, I'm doing sine 36. I usually could do divided by, you could use a fraction key if you wanted. Sine 36 divided by 3 times 4.5 equals, so I get 0.8816. Now that's what sine theta is. I want to find what theta is, and if you recall, throughout trigonometry, if you want to know what the angle is, it's going to be shift sine, isn't it? So I'm going to go shift sine, then I'm going to do the answer from the previous version that I had. So I'm doing the, and then I get 61.84, and it says to the nearest minute. So to go to the nearest minute, there we go. Theta is equal to 61 degrees, 50 minutes, 43, which would actually be 61 degrees, 51, isn't it? If we go to the nearest minute, because once we get over 30, it takes it up to the next minute. Okay, let's see if it all passes the common sense test. Yes, we've got our angles there. Very good. Let's move on. So I've done a missing sine, a missing angle. Okay, let's do these, and we can see the only difficulty with this one is there's no drawings there. So we've just got to do the drawings, right? So that's not going to be hard. Let's do A first of all. In the triangle ABC, so I'm going to draw a triangle ABC. And generally, if you do them in the order they've got them, so A, B, C, it says angle A is 56, angle B is 75, and A, which would little a be, right? How do we know where it is? It's always opposite the capital. So if that's capital A, little a over here is going to be 15, and we're asked to find little b. Well, that's going to be on the other side from this, so we're after this. Okay, so I've got my pairs of information again. So I know I'm using the sine rule. Okay, and it's not a right angle triangle, so there's no point thinking of using SOHCAHTOA. There's no right angle there, so away we go. So up here we got A, always write the rule. A on sine A equals B on sine B. Put in the x on sine 75 equals the 15 on the sine of 56. So therefore I get x equals, I'm going to times both sides by sine 75. Cancel, cancel. Grab the calculator. So I got 15 divided by sine 56, close the brackets, times sine 75, 17.476, and we're going to two decimal places, so we get 17.48. Okay, excellent. There we go. So let's go with Let's go with B. In triangle XYZ, so we're going to do an XYZ. In triangle XYZ, X is 107. Doesn't really matter that it doesn't look like 107. Y is 45. And X equals 30. Where would X be? X is 30. It's on the other side from this, isn't it? Right? Capital X, little x. Find Y. Okay. So let's do this one. We are finding a missing side again, aren't we? So away we go. So we'll write the rule. So A on sine A, this is for part B here. A on sine A equals B on sine B. So A is my missing part, I always put first, over the sine of the angle opposite it, equals B, that's these pairs. Didn't draw my arrows, did I? Let's draw the arrows in, always helps. Helps you to line them up. So we've got Y on sine 45 equals 30 on sine 107. Then I want to get Y by itself. Do we agree? Timesing by sine 45. Always good to show the working what's going on. Cancel, cancel. Calculator time. 30 times 30 over sine 107. .182, 2 decimal places, 22.182 dB. Okay, so far so good. Okay, we've got one to go, haven't we? We'll take that off so we can just do this last one, which is C. If you're noticing there in your booklet, so it's triangle PQR. PQR. And it tells me that angle P is 118. It tells me that angle Q is 34. It tells me that P is 59.5. And Q is what I've got to find. Right. So we've got 4 elements with 1 bit missing. So we can use the sine rule again, of course. So off we go. It's going to be A on sine A equals B on sine B. Let's put in the bits. So we've got missing part first. That's Q on the sine of 34 equals 59.5 over the sine of 118. So we get Q equals times both sides by sine 34. Cancel, cancel. Calculator out. So we've got 59.5 divided by sine 118 times sine 34. Q is equal to 37.682. 2 decimal places, 37.68. Okay, too easy. Let's move on. Find the length of an unknown side x in each triangle, correct to 2 decimal places. Okay, more of the same, isn't it? So we've got, a little twist to it. I like it. We needed a bit of a twist, didn't we? Right, so I start to draw my arrows, and this is why the arrows are really good, right? I started to draw the arrows. There we go, that one, great. I started to do this one. Hang on, there's nothing on the other side. So what I've got to do is I've got to go to the side and I've got to think, can I find the angle that matches this? And of course I can. So it's a classic trick question. You got the x and the 84. This is the angle you need, isn't it? And we can do that from the angle sum of a triangle. They've got to be in pairs. So I couldn't do the 51 on this because there's nothing there. Right? Nothing goes with the 51. So I'm not going to use the 51 other than to find this angle. So let's just draw a little arrow there. And this is 180 minus 51 minus 84. Right? And the reason that is because of the angle sum of a triangle, isn't it? So it's 180 minus 51 minus 84. I get 45. Right, so that's 45. So now my pairs are 20 with the 45, x with the 84. Okay, off I go. A on sine A equals B on sine B. So it's x, missing 1, on the sine of 84 equals 20 on this one, which is the sine of 45. We've said that that's angle's 45 because we worked that out from the angle sum of the triangle. Cool. Let's finish it off then. Times sine 84, sine 84 times, cancel, calculator, 20 divided by sine 45 times sine 84 equals x equals 28.406, and going 2 decimal places equals 28.41, isn't it? 6 there, so it'd be a 41. Okay, very good. Let's do the same with this one on this side. We'll be careful here. Now that we know that there could be a few tricks, let's have a look. So we've got this. Yeah, there's a nice pair. Ah, the angle, right? Nothing on this side, so that's not, I can't use this. I've got to use this. Can I find this angle? Certainly can. 55, 57. This angle just here is going to be 180 minus 55 minus 57. Let's do that. .68 degrees. Okay, so got the angle, got my little arrows, ready to go. A on sine A equals B on sine B. So it's going to be x on sine 68 equals, let's get it right, 4.8 on sine 57. So I get x equals, calculator time, or times both sides, times sine 68 times sine 68. Cancel. I get 4.8 divided by sine 57. Whoops. 4.8 divided by sine 57 times sine 68 equals 5.3. So we get, and we go 5.306, 2 decimal places, x equals 5.31. Okay, excellent, there we go, sine rule. Enjoy.